Assalamu alaikum. My name is Mohsin Sagir, and today I am going to discuss the plasma arc welding. So, first of all, I am going to discuss the principles of operation. So, the first principle of operation is shown in the figure as the orifice shows that gas is flowing downward and the plasma is coming, the plasma metal plate is below, and the weld pool and other things like copper nozzle and the cooling water. So, next, TIG versus plasma welding comparison. So the comparison between the TIG welding and plasma welding is shown in this slide. TIG arc is not constricted and relative wide hard pattern in the workpiece. Plasma welding electrode is recessed arc is combined arc is essentially cylindrical, very little change in the hearted area. Next is arc construction. So plasma electrical current higher for current cutting, lower for welding. Orifice diameter and shape smaller for cutting, larger for welding. Type of orifice gas flow rate higher for cutting, lower for welding. Distance to workpiece. Now plasmas are arc modes. Generally used for welding work is part of electrical current circuit. Heat is obtained from anode, port, and from the plasma jet. Greater energy transfer to the work. Plasma process techniques. Very low welding currents, very stable needle-like stiff arc, minimizes arc vendor and distributions. Now plasma process techniques. Microplasma and medium current plasma advantages. Energy concentration is greater and higher welding speed. Energy concentration is greater, lower current is needed to produce a given weld, less distributions, improved arc stability. Arc columns has greater directional stability. Plasma process techniques. Narrow constricted arcs, little tolerance for joint misalignment. Now this picture shows the plasma process techniques. Plasma process techniques MMA, MAG, TIG, and PAW. These are the techniques. Now this slide shows the plasma welding equipment. So DCEN for most welding applications, AC usually square wave for aluminum and magnesium alloys, and pilot arc ensures reliability arc starting, and it obviates the need for HF. Plasma welding torch operates at a very high temperature. Cooling is mandatory. Heavy and bulky, limited on handheld torches. Alignment, setting, concentration of tungsten electrode needs precision. Gases for plasma welding. Argon for gas, steel, titanium, zirconium, etc. Shielding gas is as for TIG, shielding gas flow rate 10 to 30 minutes. Now comes the PAW plasma arc welding disadvantages. Narrow constricted arc, little tolerance for joint misalignment. Manual plasma torches are heavier than TIG torches, difficult to manipulate. More complex equipment than TIG, expensive. Except all alloys, keyhole plasma is restricted to the flat position. Now comes the plasma cutting feature, can be used with a wide range of material, limited to 50 mm thick power plate, low gas consumable, protection required from the arc glare. Plasma cutting equality. A rounded tap edge gas swirl can reduce taper up to 2. This is all from my side. I can end with plasma gauging. Lower arc stream velocity gauge is bright and clean, virtually no post cleaning required. Most used manually versus on stainless steels and non ferrous materials. So this is all from my side. Thank you.